Okay.
All right. Share screen. Looks like all my photos have disappeared. So, all right. We can do it this way. I had 8 photographs pulled up, but we can kind of go through it this way. All right. Let me do the top here. This is a copy of what I'm going to send you tonight. Okay. Tonight we'll be utilizing the shape tool. To access the tool, can you see this screen okay? I imagine some of the writing is probably a little on the smaller side.
I can't really read the writing, but I can see the screen.
All right. Let me see if I can do it this way. Hang on one sec. One, two, three. Now, when we do these Zoom sessions, do you usually do it on your cell phone or do you do it on a home computer?
If I have the chance, I'll usually pull up my computer, but sometimes it's just on my phone.
Okay. All right. It's not the share screen. Go through mobile one. All right. So to access the shape tool, you would left click the shape tool icon, which is located here in between the pipe layer icon and the arc adjustment icon. It's right here. And let me just see if I do this. Can you see this?
I only see the first image.
Okay. Let me bring it. All right. Okay. All right. So we will. All right. Man, this is rough. Hang on. No, it's not the one. You know what? I'm just gonna. I'll run through it, and I'll send you the note boards because
Yeah, that's fine.
for some reason it didn't label it the way that I would hoped, but we'll just dive right into it. All right. So, right tonight we are getting into shape tool. You can also execute this command by hitting Shift plus L. Brings up the list. Now, as I said, we have a variety of presets that are what's considered common parts. I mean, everything down to a square, flange, mounting plates, frames, triangles, I mean, the list is pretty vast. So the demonstration that I have chosen for tonight is we're going to do a 4-bolt mounting plate, okay? And if you notice, up in the parameters box, we actually have definitions that coincide with these shape parameters. We have W for the width, H for the height, D the diameter of the holes. A and B are the insets in inches from the outside edges of the material. A obviously would be in the X direction and would be in the Y direction. Play around with this, say we wanted it to be 7 inches wide and we want it to be 14 inches high. Change the diameters. We can make the holes 3. Well, looks like 3 might be a little bit too big, but say we wanted them 2. Okay. And say the offsets, we want them to be 2 inches in each direction. Also down at the bottom here, we have our insertion parameters where we can choose what position X and Y where we'd like this shape to start. The guide goes by the lower left corner of the part, just as it did in Begin Grid. But to match the rest of the presentation, we are going to make this 5 inches in width. We'll make it 6 inches in height. The hole diameter will be 1. Offsets will both be 1 in the X and Y direction. Okay. And we're going to place this at X1, Y1. Okay. As long as it's in blue, this is in template mode. This isn't permanent. Okay. Once we hit our green check mark, now it becomes a viable part. Okay. We're going to save this as shape tool mounting plate. Okay, and we'll save. We transfer this to CAM. Okay, something I wanted to show you guys in this lesson. You notice almost every time we generate a part we transfer from CAD to CAM, we have these lead-in arcs or lines. The way to turn those off, change project break settings. You want to click that. Okay. For the perimeter, that's the outside. We're going to change it to none. And for cutouts, our lead in, also change that to none. We got our check mark. And now all of our lead in arcs and lines have disappeared. One of the things I wanted to comment on, you notice almost always when the software generates a cut pattern for a square or a rectangle, it will start in the middle of one of the lines. I find it perplexing why it does that, but this is just the software's interpretation of the correct way to cut the object. Now, in the sheets I'll be sending you, it shows the cut order. This is 1, 2, 3, 4, and then it will transfer here and actually cut the rectangle out last. I'm not gonna create a G-code file for this because I actually already generated one earlier, and in the sake of time, I'm just gonna pull that up. That was the flange. Okay. All right. You can see we have the cut pattern laid out just as I had specified earlier. We get into the G codes. I'll also be sending this to you. I have annotated each line, okay? And it will coincide with the charts that I have provided as far as cut sequence. A couple of things that we've had to do. We have to duplicate each of the circle lines. This particular program has chosen counterclockwise rotations. I've copied them and pasted them below and labeled a duplicate command to ensure circle cut quality. And I went in and put all the torch ons, torch offs in the proper positions. And you can actually review that. And down lines 40 through 52 are the commands to create the rectangle. So it's a pretty standard G code that we would normally do. I just have put the definitions in with it. Okay, we're going to go ahead and hit play. I have the speed set really high to save time. As you can see, it moves to the middle of the right line, which just seems crazy to me. Okay, so pretty cut and dry. And you can convert any of those, any of these shape tools, say we wanted to do a flange. Okay, we'll come up to our shape part tool, click on flange. Looks like the outside diameter is 10. The inside diameter, we're going to change that to 6. Make it even numbers. You know what? We'll make it 5. Another thing, if you highlight any of the parameters and you either scroll forward or backward, you can change this manually till you get it where you want. Okay. All right, so we'll leave it at 5. Hole count, same thing. We can start with, looks like we could get up to 15 mounting holes, but we're going to take it down to 4. The diameter of each hole, it's at 1.5 inches. And the radius from the very center of our object to the arc to the center point of each one of these bolt holes is 3.9 inches. Okay, we'll check this. We will save this as shape tool, flange, 5, because you're group 5. Save that. Take it to Cam. Cam, if he has an interesting cut pattern, we'll create a G code. Call this the same thing. Shape tool flange 5. Save it. And we're probably going to get some error messages because we are right on the edge of our X and Y axis. And as you can see, it overlaps our work parameter. But there's something I'm going to introduce you tonight to compensate for that. All right, let's load our G-code file. See, instantly we get envelope errors, okay? Okay. All right, set it this G-code. For the sake of time, I'm not going to duplicate everything. Let's label our point of origin. Okay. Next. Okay, we have after our G603, we got M50 torch on. After this line, we have our M51 torch off. Raise our torch. This is our next position. Okay. Let's tell our torch to turn on. Make our cut. Torch off. Raise our torch. We have our next position. All right, tell our torch to turn on. Tell it to turn off after we cut our circle. We raise our torch. We have our next position. We're going to lower the torch to operating height, which is 0. And 50, torch on. Torch off. Next position, lower the torch, operating height. Here we have our next position, lower the torch. Six or 3, turn our torch on. I am still working with flash cut. Our objective is to do some macro programming behind the scenes to where we will no longer have to type in torch on or torch off or make any adjustments. it will go right from drawing to G-code generation to cut. And we're getting pretty close. Okay, and this is what I wanted to show you. We're going to get some error codes. Because of our machine envelope. Okay, we close this. We could force this to cut, but it's not going to be right. Now this is what I wanted to show you. This is a new G command. It's called G52. Okay. So what G52 does, we can actually move this to a new virtual 0, position, okay? If we were to move this shape in an inch and up an inch, we wouldn't get these, we wouldn't have the problem with this execution. G52, X 1.0, Y 1.0. Okay, we're gonna save this. We're gonna close it. Now you can see it's actually moved the start point of this up an inch and over an inch. And that's called G52. G52, you can code a program and move it to wherever you want. And when you want this to end, after our G00, Z -0.5, you put G52 in again, X 0.0, Y 0.0. Okay. And now it returns to our home position. Now, this is something interesting I wanted to show you. Okay, let's say, all right, we went in 1 and up 1. Let's say we go in 1 and we go up 12. Okay. All right, down here, we can put in another G52 command. G52, we'll say X1, Y12. Okay. We're going to hit enter. We're going to copy this whole program from here. Actually, I'm sorry. Control C. We're going to paste it. Control V. Save it. Close it. Now we've just duplicated that part. This is another way that we can do multiples with this G52 command. We'll work some more with this tomorrow, but the reason that I wanted to bring this up, I actually did a manual coding version of our original part. Okay, I programmed this myself, and I programmed it from a 0, position, this flange. But as you remember, our flange started at X1, Y1. If I were to hit play, it's going to cut in the same sequence. 1, 2, 3, 4. Now the difference is my square is going to start down in the corner. It's going to trace all the way around. And then it's going to stop there. Now, I programmed it from a 0 position, but I went in at line 4 and I put a G52 and I wanted to start my drawing at X1, Y1. So this basically makes X1, Y1 a new 0 until you enter another G52 command for the actual 0. Okay, say we want to duplicate this. Let's say we want one to start at X7, Y1. Okay, come down here, put in a G52, X7, Y1, and we're going to copy everything from our previous G52 command to our last G00. We're going to copy it. We're going to paste it, save it, close it. Now we have another one right next to it. Are there any questions about how G52 works?
No.
Okay, in the notes that I send, I actually do a comparison of the computer-generated G code versus the G code that I wrote with the G52 addition, so I could put it in the proper place. Let's say we want to do another one at X1, Y8. You can continue this forever. G52, X1, Y8. Copy everything from our first, just under our first G52. Now, since we have a code right next to it, we're probably going to end up with 2 more. Control C, Control V, save it. So now we have another one. And we can keep this on and on. We can pick different coordinates in the grid and keep duplicating these parts. Works a lot like beginning grid, except you're just using a G52 code. You're picking new coordinates and you're implanting those coordinates. Put one next to this, we would be at X7, Y8. Come down here. G52, X7, Y8. Copy everything from line 5 on down. Actually, you wouldn't have to copy everything. You could just copy it to the next G52, but it's not going to hurt anything if you do it this way. Control C, Control V. Bam, we have another one. And if you notice, every time I copy this, I always end it with a a G52X0Y0 command. That way it brings it back to our point of origin, our absolute zero. Okay. It's just for kicks. Let's see what happens if we play this. Should run pretty fast. Yeah. The whiteboards that I send you, you'll notice in my manual programming, I've used a combination. The first two, I use the OR method for programming the circles. The second two, I use the INJ method. I'm gonna stop this, refresh this, and we are going to take everything out up until so still have our two. Find where our second one is. Somewhere in the 50s. Here. Actually, I left a piece out here. There we go. Okay, so any questions on G52?
Nope.
Okay. I am going to stop the video here, and as I said, we will